Today we are going to discuss about the scalar product of two vectors, and that is also known as inner or dot product. As we know that if we multiply two numbers, then the product as we know that it is always a number. But if we multiply two vectors, then the product must not be necessarily a vector. It can also be defined as a number or a scalar. So let us define a scalar product of two vectors. So we are going to define about the scalar product of two vectors. Let us define the scalar product of two vectors. Say a vector and a small b vector is defined to be a scalar whose magnitude is equal to the product of their length and the cosine of the angle between them. Symbolically we can write it is denoted by a vector dot b vector. In multiplication we use this dot. So a scalar product of two vectors is also called a dot product of two vectors. Mathematically, a scalar product of two vectors, a vector and b vector, can be defined as a vector dot b vector, and this one is mathematically a vector and b vector can be defined as a vector dot b vector is equal to modulus of a vector times modulus of b vector times cos theta, where theta be the angle between two vectors. Now there is one note and we have to remember it. If a vector modulus of a vector is written as a small a and b vector is written as a small b, then the above relation can be written as a vector dot b vector is equal to a dot b dot cos theta, where theta lies between 0 degree and 180 degree. A scalar product is also known. A scalar product of two vectors is also known as the direct product. Let us discuss about some special properties of the scalar product. So the special properties of a scalar product. So let us discuss. The first one is, if a vector and b vector are in the same direction, that is theta is equal to 0 degree, then cos theta is equal to cos 0 degree is equal to 1. So a vector dot b vector is equal to modulus of a vector dot modulus of b vector times cos theta is equal to modulus of a vector dot modulus of b vector dot cos 0 is equal to modulus of a vector dot modulus of b vector, as we know that the cos 0 degree is equal to 1. So is equal to modulus of a vector times modulus of b vector remain. So therefore a vector dot b vector is equal to modulus of a vector times modulus of b vector when theta is 0 degree, that is they are parallel to each other. At that time the condition is a vector dot b vector is equal to modulus of a vector and times modulus of b vector. Here if a vector modulus of a vector is equal to modulus of b vector, then a vector dot b vector is equal to modulus of a vector times modulus of b vectors, as above given. Here is, and which implies a vector dot, let us instead of writing b vector we write a vector simply, is equal to here remove this one, simply say that a vector is equal to b vector, or say b vector is equal to a vector. At that time we can write like this, a vector, which implies a vector times a vector is equal to modulus of a vector square, modulus of a vector square. So which implies a vector dot a vector is equal to, we can write simply a square, simply a square. So this is our first condition when theta is equal to 0 degree. Now let us discuss the second one. Second, if a vector and b vector are perpendicular to each other, that is if theta is equal to 90 degree, then cos theta is equal to cos 90 degree. And what is the value of cos 90 degree? as we know that it is 0, it gives 0. So now we have by the above relation, as we defined above, a vector dot b vector is equal to modulus of a vector modulus of b vector cos theta is equal to modulus of a vector modulus of b vector into, as cos 90 is equal to 0, so here we put 0. So therefore a vector dot b vector is equal to 0. So when theta is equal to 90 degree, the product of two vector is equal to what? 0. Now this one is the second one, and now let us as we know that the from the definition of a scalar product of two vectors, we can find the angle between two vectors. We can find angle between two vectors, that is, we have to find the theta. We have to find the theta in terms of degree. So because we know that a vector dot b vector is equal to modulus of we have already mentioned above, cos theta or cos theta is equal to a vector dot b vector by modulus of a vector modulus of b vector, which implies theta is equal to inverse of cos a vector dot b vector by modulus of a vector modulus of b vector. So in the next video we will discuss about the alternative method to define a scalar product of two vectors.